Let's take a look and see what we got here. So in terms of information, we've got power at 1 and power at 2. We got reactive power at 1 and reactive power of inductor 2. So if I was to think in terms of what in this triangle here could I put in there? Because this is a series circuit, and I've staggered them like this for a reason, just to show you, it makes no difference. I mean, if I was to take this end here and straighten this whole thing out, it's one current path, and my total value of resistance, not opposition to current flow, but total value of resistance is going to be the sum of the individual resistors, and the total value of the opposition to current flow, or the inductive reactance, is going to, in a series circuit, is going to be the sum of the individual inductors, the reactive power of those. So I could say, what I'm saying is that, well, these two would add together and these two would add together. So on here, I could put those values here. So I could say, okay, well, the value of the true power resistor is 56 plus 44. So that's 100. And it's 100 watts. This is true power. And then doing the same thing for a reactive power being total of 152 plus 88. So I have a reactive power of 240 VARs. So now I say, okay, I can get my apparent power. So if I can get my apparent power and I know my RMS, then I can get my IT, right? So keep working on that. I'll be back in 1 minute. All right. So if you do your apparent power, true power squared plus reactive power squared, get an apparent power of 260 VA. Put that there, 260 VA. And just using Ohm's law, we can say that I is going to be equal to P, or apparent power, over my ERMS of 130. So I could say 260 divided by 130 is going to give me my current, which is going to be 2 amps. Now we've got a lot more information to go by. So we could find our our voltages. So we can find ER1, so the voltage across resistor 1, resistor 2, voltages across the inductors 1 and 2 as well. So let's take a look at number 1. So ER1, so I would say the voltage at resistor 1 must be equal to the true power of 1 divided by the amperage of 1. So in this particular case, I've got 56 watts divided by 2 amps. I end up with 28 volts. And then doing the, why don't we do the resistor 2 first? We'll keep them all together up here. So for resistor 2, I've got, 44 divided by 2. So I've got 22 volt drop there. All right, and moving on to our inductors. So my voltage across inductor 1 would equal my reactive power of 1 over the amperage of inductor 1. And my reactive power of 1 is 152 bars divided by my 2 amps. Gives me a total of 76 volts. Okay, and then EL2 will just be the reactive power of 2 divided by the current of 2, so 88 bars divided by 2 gives me 44 volts. Okay, so I've got 28 and 22 across my resistors. That is the value of voltage drop across the resistors themselves, 28 and 22. So that's actually 50. So the voltage drops across my resistors, I would say, would be, 50 volts. And then the voltage drops across my inductor, I got 76 volts plus 44 volts. So my voltage across the inductors are 120.